So hi guys, now we are going to see the answer for the quest, antennas and RF concept quiz questions, part 4. Okay, so far we have looked at part 1, part 2, part 3 in previous 3 videos. Now we are going to see for part 4, electric and magnetic fields equivalent in circuits respectively. So the equivalent of electric and magnetic field in circuit point of view, it is voltage and current, not current and voltage, because we have to be very careful. Electric field corresponds to voltage, magnetic field corresponds to current, because current only when flow of current is there, magnetic fields gets generated. Okay, in field theory, and electric field is there, then it corresponds to, because when you have a potential difference between these two charges, then that is called as electric field. So that we call it as voltage. Okay, so salt. Next is power in circuit corresponds to pointing vector. Okay, pointing vector S is multiplied equal to E into H, E cross H. Okay, could have studied the formula. So E cross H, E cross H is nothing but your VI. Okay, VI in circuits. Power is equal to V voltage into multiplied by current, right? Similarly, we have in fields E and H, E cross H. Okay, besides vector, because it's a point function. That's why we use n cap also a normal vector. So E cross H. Okay, then which is nothing but your pointing vector. Okay, so that is nothing but power and circuit corresponds to, because power formula is V into I. So similarly we have in fields also, electromagnetic fields also, like pointing vector, which is E cross H. Okay, so which in context with the previous question I have posted here. Next is pattern shape is independent of distance in far field. Correct. Okay, in far field, when the way we enter into the far field, there is no disturbance to there is no not like unlike near field, there is no disturbance for the waves. So that's why it will not change the pattern shape almost. Okay, principal planes are azimuth and elevation. This we have been discussing so many times. Is return loss is a positive value? Yes, of course. Last video also we saw that return loss is a positive value. Next is radiation resistance is a real resistor? No. Oh, sorry, this answer is wrong. Actually, it's a no. Okay, the answer is wrong, because it's a false. It's not a real resistor. Okay, radiation resistance is a real resistor, not a real resistor. The answer is false. So please, sorry, because answer is false, because it's not a real resistor. Okay, antennas, in antenna will have a its own resistance, like antenna is made up of several dielectric and rod or a wire or any kind of thing. So it has the resistance in it. So that's why we call, that's what we the resistance that causes the radiation. Okay, that is responsible for radiation is called as radiation resistance. It's not a real resistor where we place the it is not that we place some resistor in the antenna. So that is not that. So it's a false is the answer. Sorry for that. So true is not an answer. Sorry. Okay. Beam area is the circuit parameter? No, it's not a circuit parameter. It's a field parameter. Okay. Okay, what is the fundamental element of radiation? Is accelerated charges. So static charges that does not cause any radiation, because it will be a kind of capacitor only. So it will it will be there, but it will not have any movement. Therefore, the radiation will not be there. So that's why fundamental element of the radiation pattern, fundamental factor or parameter of the radiation pattern is accelerator charges. EM wave varies as a function of both position and time. So that's why and I think you should remember, when you look back to antennas and RF concept video, I think you mentioned some equation, like where the variable was time as well as the position, because dou t by dou z, like that. Some will have a dou t, some will have a dou z also. So that's why. So it depends upon the why, because for example, you are capturing the, you are listening, you are measuring the field at this point, for example. Okay, at one point of time it will be a different value, and another point of time it will be a different value. That's why in that equation it is as a function of t is there. Next is that, so if I am, so this at the same time I am measuring the field at two different points. Okay, two different points. So obviously this will not be same as that of this one. Okay, so that's why varies as a function of both time and position. The last question for this antennas and RF concentration is free space impedance value is 377 ohm. So please be careful while handling this, because 120 pi is also 377. So we have to be very careful in this. Okay, thank you all, keep watching, thank you, bye bye.